Conduit, Comcast, Intel Download Center, Accenture, McAfee Service. While some of these names might seem familiar, and some may not, what all of these websites and many, many, many others have in common is the fact that they're all built on the foundations of modern web application frameworks. Frameworks such as ASP.NET and Mono, frameworks that make use of components called server-side web controls. And that means that they, and any other websites which are using the same technologies, may be vulnerable to the attack that I'm about to present. So hello everybody, my name is Shay. I'm the CTO of a group called Hectix, which is an advanced security center of Ernst & Young. Hectix used to be a privately held boutique company, but it was bought by Ernst & Young in 2011, and since then joined the worldwide group of Ernst & Young security centers. Over the past 3 years, Hectix has been involved in the development of several mid-scale and large-scale open source projects, and you can check them up online. And I'm here to present a new open source project that Hectix has been developing for the past year or so, which is currently nicknamed SCIP, an acronym that stands for Server Control Invisibility Purge, an OWASP ZAP extension designed specifically to assess the security of ASP.NET and Mono, and do neat things with it. Now, instead of delving into the mechanics of this attack directly, I want to give you a short demonstration that really emphasizes exactly what is this attack, what does it do, and how do we as pen testers benefit from it. So what you see in our nice application, our nice demo application, is how two users view the application, view the same page in the same application. On the left side, you see how an administrative user, a high-privileged user, views the application. And on the right side, you see how a low-privileged user views the same application. And you'll notice that the admin user has an extra button, the red button, which initializes account passwords. Now, if we'll check the HTML of the admin presentation, you'll see that the name of that button is button 2. Okay? And if we'll search for the same button in the low-privileged user presentation, you'll see that it doesn't exist. There isn't such a button, which means that ASP.NET doesn't even render the button in the client-side presentation. However, using a tool such as SCIP, simply by calling ZAP proxy, while the SCIP extension is installed, you can immediately see that this page contains an invisible control which is exploitable. Furthermore, by right-clicking on the page and activating SCIP, in a matter of seconds, you can enumerate the name of the server-side control and execute the server-side event, which is an administrative event associated to that control. Bold statements, I know, but by the end of this presentation, you'll understand why it's all true. Now, this feature initialized the password of users, and that's exactly what would have happened if I would have executed that same operation from the admin interface. Okay? So what do we have here? We have a collection of attacks that we currently classify under the name ODSEC, execution of dormant server-side events and controls. And what can we do with it? Well, we can execute operations or activities that were designed for high-privileged users, such as administrators. We can gain access to dormant code in ASP.NET, Mono, and similar applications that was designed for testing purposes. It may be vulnerable to attacks that the rest of the application is not vulnerable to. So we might have a button, which is a test feature button or whatever, which is vulnerable to SQL injection. The rest of the application is not vulnerable to it. And the developer decided to protect that button by turning it invisible. We'll be able to detect it and exploit it and execute the event itself. We can gain access to testing features that can corrupt the data, and so on and so on and so on. So where does ODSEC, where does this attack fit in the puzzle that is penetration testing? These days, modern web application frameworks, such as ASP and Mono, have a lot going for them in terms of security. Let's take ASP.NET, for example. ASP.NET has numerous security features. It has the event validation mechanism that can turn even a simple parameter manipulation attack into a nearly impossible task. It has digital signatures and MAC, message authentication code, that can prevent the attacker or the potential attacker from sending values from the client side that the developer did not intend him to send. There's built-in regular expressions in controls. There's a built-in XSS filter that prevents most of the XSS payloads from actually working. So we, as pen testers, need an edge when assessing the security of those platforms. And I believe that that edge is the increased attack surface that these applications have. While normal, standard web application platforms such as SP3, PHP have entry points such as web pages, web service methods, and global modules such as filters, rich web applications, modern web application frameworks with server-side web controls such as ASP.NET and Mono have an additional independent entry point. And that's the events associated to server-side web controls. So what is a server-side web control? A server-side web control in general is a control, a server-side control, which is implemented in both the client side and the server side. In the client side, it's usually represented in some sort of HTML or control or set of HTML controls, and in the server side, it's associated to a separated code segment, a separated event, which is independent from the rest of the page, or almost independent. So the way it's implemented, the client side will have some sort of HTML control that has a JavaScript event that calls the doPostBack or the callback method, which in turn will send 3 parameters to the server, or mainly 3 parameters. The event target, which generally states which control to execute. The event argument, which generally states which arguments to deliver to the server-side event. And the view state, which is a base64 serialized object that contains all the properties that the page originally had. Now, this field has a MAC on it, a message authentication code, which is designed to prevent users from altering the content of it. It's like a signature, okay? And to actually implement that protection, the platform has an optional feature called the event validation. Now, the event validation is another hidden HTML field, which is very similar in structure to the view state field. It's a base64 serialized object, but this time, instead of containing properties or values, it contains the hash codes of every single visible control presented to the user. So any visible control that isn't visible, will have its hash code included in the event validation field, in addition to the hash code of the view state itself, okay? Which is the first one here. Now, this field also by default has a MAC on it, so nobody will tamper with it. And that's really the main defense .NET has against the execution of invisible events associated with invisible controls. So if I'm trying to send the name of a button in the event target to execute its event, and I don't see that button in my presentation layer, .NET will know that that event is unauthorized because the hash code will not appear in the event validation, okay? And I am not supposed to be able to alter that content due to the MAC. And that was the first punchline of this presentation comes into place. Since that actual format causes the platform to reveal the existence of invisible controls. When there isn't any invisible control in ASP.NET and Mono, the Viewstate field won't contain anything interesting. However, when some control is turned invisible using code-level assignments, server-side code-level assignments, the Viewstate will contain a visible equals false property. And you can actually know how many invisible control the page has, not only that it contains visible or invisible or disabled controls, okay? So simply by using SCIP to crawl the application, you'll get exactly which pages have invisible controls in them. And we exploit exactly that behavior to tell you which pages have such controls. So what is an invisible control? what do we consider to be a dormant event? There are several archetypes, okay? And we're going to go over them just so we'll know what we're going to crack later on, okay? So the simplest form of an invisible control, which isn't really invisible, is a commented out control. A commented out control, I mean HTML commented out control, is generally any server-side control in which the developer placed HTML comments before that, okay? Before the control. Place the control in the context of an HTML comment. But there's plenty of reasons that developers do that. They want to delete the control and they don't understand that .NET ignores HTML comments and renders the control both in the client side and the server side normally. The second type is more dormant than invisible. That's a disabled control. And I mean server-side disabled control, okay? And that's generally control that had the enabled property set to false in the server side. And that causes a number of things to happen. A, the control is grayed out. It has the disabled property in the client side on, okay? And you can't click it. And even if we delete the disabled property, that control is not associated, as you see, to a do post back call. There isn't any JavaScript event. So even if we click it, nothing happens. Or nothing happens in the client side at least, okay? The third type is the real deal. That's a truly invisible control, a control that had the visible property turned to false in the server side. And that control isn't even rendered in the client side, except for the disclosure in the view state I just demonstrated, okay? The last type is an optional event of an existing control. Certain ASP.NET controls can be associated to more than one server event. Take calendar, for example. The calendar control can be associated to two events, change month and change day, okay? So, in general, to abuse this functionality, to execute odd-sec attacks, we generally play around with disks, okay? We play around with the various features of dormant and invisible server controls. And the simplest method to begin with is, of course, uncommenting them. The first type of invisible control was a commented out control. And that's not really invisible. And the simplest thing we can do to crack it is simply to uncomment it. Now, that attack will work regardless of the view state MAC and regardless of the event validation mechanism. So let's see a live example. Let's use bare proxy in this demonstration. So you won't think I'm completely sold out only on OSP ZAP, okay? I'm being fair here. So I have a page here that contains a commented out control. I'm going to forward the communication through burp and intercept it, okay? Just so I'll be able to remove the HTML comments of the surrounding the control in the response. And you'll immediately see that a yellow control was added to the presentation layer. Before I'm going to execute that yellow control, I'm going to show you just to verify that that page, the first page, page 1, section 1, has the event validation feature on and the view state feature on, okay, view state MAC, and executing that commented out event will still work, okay? Nice, neat trick, but that's honestly not really considered hacking. It becomes a bit more interesting in the second type, which is a disabled control. So, when trying to defeat the disability property, okay, we have to do something which is very similar to uncommenting controls. But this time we have to forge a do post back call in addition to that. Now, that attack works again regardless of the view state MAC and the event validation mechanism. That's because the disability feature isn't really supposed to be a security feature. It works in ASP.NET cleanly, and it works in mono if you delete the view state field completely, okay? So let's see that in action. We'll do the same attack using burp in the same page. There's a button here which is disabled, the send event notification button. We're going to forward the communication to burp again, okay? And in the response, we're going to delete the disabled property so it won't be disabled from both the text box and the button, And we're going to forge a do post back call. And that's not really as complicated as it sounds. All you have to do is generally copy an on-click event. And instead of sending the original name of the control, we're going to send the name of the current control. In this case, button 3. Okay? Just by doing that, despite the fact that event validation is active and Viewstate is active, the server-side event associated to that control will work. Okay? Piece of cake. Now, we can do that manually, or we can do SCIP. SCIP, the same way it detects invisible controls, detects commented out controls and disabled controls. Okay? Right-clicking on a page will present exactly which controls that are commented or disabled it contains, and we'll be able to execute their event. Okay? The same way. It becomes much more difficult to perform those attacks when we're facing an invisible control, which is a much tougher opponent in general. So, the invisible control, or the invisible property, is the real deal. That's what actually was supposed to be a security feature in ASP.NET and Mono, okay? Nobody relied on commented out controls or disabled controls. Nobody educated developers for years to use the disabled properties. However, we did educate developers for years to use the visible property for security. And there are many ways in which we can execute invisible controls. But let's start with the simplest ways. And that's when one of the security features that .NET already has is disabled. If you remember, earlier I discussed two main security features, the Viewstate and the event validation, both designed specifically to prevent attacks such as execution of events that are associated to invisible controls. What happens when one of those features is disabled? So let's start with the first scenario in which the event validation is on and the Viewstate is off. The event validation is off and the Viewstate is on. If the event validation is on, it doesn't really matter that there's a MAC because the server doesn't perform any verification. We've just disabled it. So the attack will be very similar to what we did with disabled controls. Just instead of forging an event, we'll forge an entire control. Let's see that in action. Let's do the same. Let's take a page that has the MAC enabled and the event validation disabled. Let's verify that in the code. Page number 3. Event validation disabled, MAC enabled. Okay? We're going to intercept the request, intercept the response, and add an entire control. Now, assuming we guessed the name of the control, and I'm going to get to how later on, there's a very good way to guess that name. Assuming we guess that there is an invisible button 2 in this page, all we have to do is really forge an entire control with a do post back, proper IDs, and some sort of alias that will recognize, such as evil, evil, evil. Okay? The only thing we have left to do is click it. And since the event validation is off, there isn't any server-side verification, and the attack is performed normally. If we'll do the same from the admin browser, we'll get the same result. Okay? So that's the first method. And it's pretty common because there's plenty of reasons that developers disable the event validation field. Like anytime a developer wants to make a list box or a combo box, which is a server-side control, more dynamic, alter the content from the client side without sending the request to the server, he'll need to disable the event validation. Many templates in the internet that implement custom control actually disable the event validation in those controls, and thus in the entire page, and so on and so on. But the process becomes much, much more complicated when it's the other way around. When the event validation is on, but the Viewstate MAC is off. If the event validation is on, it means that .NET verifies the structure of the event validation field. It verifies that the type or name of control that we send from the client side, the hash code of that control is included in the event validation field. So in order to actually execute the server-side event of an invisible control, we'll need to reconstruct the event validation field. Now, obviously, I don't see many pen testers these days that do that manually. I mean, computing the hash code of every control you want to execute, that's a tough job, even if you know the formula, okay? However, SCIP that does that for us. We can use a tool such as SCIP to immediately recompute the Viewstate field for us and the event validation field by accessing a page that has the event validation turned on and the Viewstate MAC off, okay? SCIP already identifies those scenarios. We can enumerate the name of the control, and I'm going to touch on that in a second. And SCIP will recompute the event validation field for us and include the name we're trying to execute within it. So the platform, when it verifies the event validation field will execute the event. Since there's no MAC, there's no actual signature, we'll be able to do that. Okay? So how do we actually enumerate the name of the control? That process can rely on another very interesting .NET behavior, which is actually, I don't know, it's pre-ordered, I guess. We couldn't have hoped for anything better. .NET has a very interesting behavior. When you send the name of a control that exists in the page, is invisible, and you're not permitted to execute it, .NET will throw an exception. Okay? Let's see that behavior in action. If we have a page, let's say page 2, okay? It has the event validation turned on, okay? We'll intercept the request right now and execute a control that we're not supposed to execute. Button 2. Burp doesn't reconstruct the event validation field, okay? Remember, button 2 is an invisible control I cannot see and is not included in the event validation field. And what .NET will respond with is an exception, an invalid postback exception, to be exact. However, if I'm going to try and execute a control that does not exist in the page at all, such as part my German button 999999999, okay? Nothing's going to happen. There won't be any exception whatsoever. So we're actually able to abuse this behavior to know exactly what's the name of the control. And .NET actually makes it even easier for us due to the existence of naming conventions. And we're going to touch on that later on. Even if there isn't any error-based response, we can still enumerate the existence of specific controls using a blind approach, just by comparing the responses in a similar way to what Crowbar or JBA do. Those of you who know those tools, okay? Now, the naming convention of ASP.NET makes it very easy for us to execute those events. Now remember, if we executed an event or enumerated its existence using the error-based approach, there isn't any risk because we haven't actually executed the event. We just found out it's there. But when we do it in a blind approach, there is some sort of risk in the perspective of testing because we execute the event. So if it deletes the database or whatever the cause does, that enumeration method will cause it to actually happen. Now, the naming convention in .NET is very simple. That makes the process even simpler than running a tool such as Deerbuster, which enumerates files and directories. Okay? Since the naming convention of controls by default is the type and some sort of sequential number, such as button 1, button 2, button 3, text box 1, text box 2, etc. Okay? And even if it gets more complicated, such as in certain versions in .NET, or when you use a master page, the convention is still something that we can predict. And in the worst case scenario, when it's a custom convention, we simply do a dictionary attack, just like we do in Deerbuster. Nothing that is impossible. So it's a lot easier to enumerate those controls. So what do we have so far? So far, we executed the events of commented out controls and disabled controls when all the security features were turned on, and we executed the events of invisible controls when the protection mechanisms when one of the protection mechanisms was turned off. The same applies to optional events of controls. The same restrictions. Well, if we'll take an event of a control which is associated with more than one event, such as a calendar event, the only difference is that we'll have to fuzz an additional parameter, okay? So far, we fuzzed the event target parameter, which signifies which control to execute. When trying to select which event to execute, we'll have to fuzz the event argument. So in the calendar example, when we'll send a capital V in the beginning of the event argument parameter, it will execute the change month event. When we'll send it without a capital V, it will execute the change day event, okay? And the convention obviously changes from one control to another. So the problem here that so far we had some serious restrictions. Although some of those misconfigurations are common, we still are limited to executing invisible controls only when the developer made some sort of serious misconfiguration mistake, okay? But in reality, I probably wouldn't be here in Blackhat presenting if I didn't have any method to bypass that, okay? So some neat tricks for a nightmare mode, okay? Some neat tricks for a nightmare mode. A mode in which all the security features are turned on, both the Viewstate MAC and the event validation. There's a couple of ways to bypass those security mechanisms. And one of those, it actually relies on a vulnerability that all of us classify as a low severity vulnerability: caching. Those of you who perform penetration testing and deliver reports to customers usually put that way below in your findings tables, okay? And caching actually in .NET contains a very, very interesting information for us as hackers. When a page is cached either in the browser of an administrative user or in an indexed page, it was indexed by Google or Wayback Machine or whatever, or in a proxy, which is somewhere along the way, just by getting the view state and event argument fields of another user or of an obsolete version of the page in which the control was visible, we are able to do something very interesting. We are able to replace our own fields with the fields of the other user of the obsolete page, and we'll be able to execute any control that user was able to execute in our context. Well, let's see that in action again. If you have the admin page right here, okay? Let's go to a page that has all the security features turned on. Page 1. Let's hope the demo will work this time. This page, page 1, has all the security features turned on. Let's just verify that. Event validation true, MAC true. And we won't steal that user session. Instead, we'll steal the event validation field and Viewstate MAC field from the cache. Something we can do in a number of ways, even using application level attacks such as clickjacking, cross-site scripting, whatever. By gaining those fields and replacing my own fields with them, I'll be able to execute anything, any control in the same page that admin can. Let's intercept the response again to that page. Let's replace the Viewstate field and the event validation field that I currently have with those I got from the admin cache. You'll notice the view state of the admin is much smaller because there isn't any visible equal false property. We'll replace the event validation field the same way. This time it will be a bit bigger. Okay? Now, all we really have to do is execute the event that we plan to execute. We're going to execute button 2. And voila, the server-side operation is being performed simply by stealing somebody's cache, okay? But then again, I have to steal somebody's cache. I have to go and get the cache from an index page in Google. That's a lot of work. It can be even simpler than that if the developer is using something called callbacks instead of postbacks. Callbacks is a very similar mechanism to a postback mechanism, only there's a couple of differences. A, the callback ID and callback parameters are used instead of the event target and the event argument. And they mean the same. Generally, callback ID is which control event, and callback param is which parameters to deliver to that event. However, in the case of callbacks, the developer is actually implementing the entire callback event in the server side, including the event validation. So if for whatever reason he wanted to make list box or the combo boxes dynamic, he had some exception and thought the event validation feature is the one causing them. If the developer either comments or deletes the code level validation, the attack will work regardless of any configuration in that page. So we may see a page that has the event validation active and the view state map active, but since the developer is using callbacks and disables some sort of line of code, the attack will still work. We'll be able to execute the events of invisible controls despite any security mechanism that the system has. Which means that in real-life scenarios, honestly, I don't see how invisible controls can really survive an encounter with a real-life hacker. So that was IDKFA, by the way. How many people know what that is, IDKFA? Hands up. Ooh, not many Doom fans. Tough audience. So anyway, so what can we do to mitigate the risk from these controls in any platform, ASP.NET or whatever? By the way, 2 weeks before the conference, we proved that this technology works as is on JSF as well, okay? I have demo movies here. I probably won't have time to show them, but anyone that wants to see them can come and talk to me later on. So in order to mitigate the risk from this attack, we can do a number of things. A, we cannot rely on the security of disabled controls, and the same thing applies for commented out controls. It's not a security feature. It wasn't really designed to be a security feature, okay? And as a result, we have to remove any unnecessary dormant events from the page, delete them. One of the most effective countermeasures we can do, that's the fourth one, is to implement code level privilege validations in the event itself. Usually, we perform privilege validations at the upper section of a page, but we can add a validation code for privileges in each and every event of controls, and that will prevent any single one of the attack instances as I presented. Just doing that, okay? So that's probably the most efficient security measure that we can take. In addition, it couldn't harm actually enabling .NET security configurations, such as enabling the MAC and the event validation, which is what we're supposed to do anyway. And since caching becomes a bigger issue in .NET, it's probably wise to disable it in any page that contains code that can do significant things, okay? So we can disable the cache for a browser or a proxy using the sample code you see here. And we might want to do the same for search engines by using the robots file, okay? Right here. Prevent them from crawling our application and indexing the various pages, at least for platforms such as ASP.NET and Mono, okay? So the SCIP project can do a number of things for us. In general, we learned that we can always execute the events of commented and disabled controls, regardless of any security features, except the code level validations I just demonstrated, okay, I just presented. We can do the same for invisible controls and optional events when either the MAC or the MAC is disabled or the event validation is disabled. And we can even do that when they are both enabled if either we can gain the cache of a high privileged user or of an obsolete version of the page that had the controls, or the developer made the fatal mistake of using callbacks and disabling the event validation line, okay? In any one of those, we can do that. There's an additional scenario we can do that that I haven't presented in this talk because it's pretty far-fetched. If you have a shared hosting model, we're actually using the same machine key. So if we have our own .NET application on a server that hosts several, we can do the same using the machine key, okay? But it's really far-fetched, so I won't discuss this one. The SCIP project can be downloaded from its Google Code homepage. And furthermore, we can also go download it from the neat new Zap feature called Marketplace. OSP Zap has a built-in marketplace for extensions. You can actually check for updates, download extensions, and SCIP is already in there. It's super convenient, and I can't express how much I like this feature, okay? I can say plenty of things about it, but again, I'm trying to be as objective as I can, okay? So SCIP currently does a number of things. It locates the existence of invisible controls, commented out controls, and disabled controls. In addition to that, it enables us to execute all those scenarios we have demonstrated, and it even enumerates the name of controls in error-based scenarios. And those dictionaries are files. They're customizable. You can custom the files and check for additional instances that we haven't figured out, that we haven't thought of. However, only in the next version we'll be able to do the blind enumeration because we need to integrate the project with Diviner, another project we are currently developing, with a feature that Diviner has to really do a very good blind diff method, okay? So in the next version, we'll probably be able to enumerate using blind enumeration as well, okay? Those of you who are interested in the subject, I can highly recommend the blog of James Jardine, an awesome security expert that has plenty of amazing content on the subject, okay? You get plenty of ideas from James Jardine, and the rest of them are really things we discovered during the research. And that's pretty much it. Any questions? Yes?
If you're doing the cache reuse, but the view state has been tied to the session ID, does it break?
Yes, it will break, okay? But by default, there isn't any tie. The developer has to implement that tie to the session ID, okay? Okay? That can also cause functional problems if you're using such as a mechanism such as persistent cookie or whatever, okay? So there's a number of reasons why people won't do that. Any other questions? Was I that good? So thank you very much, everyone, and enjoy the rest of the conference.